We have a curve that has the equation x to the third plus y to the third equals 4xy. Then we're told that the tangent to this curve is parallel to the x-axis at the point where x is equal to k. K is a value that's greater than 0. Use implicit differentiation to show that dy dx is equal to this expression over here. Well, we already know that dy dx means what? The derivative. And so we're basically finding the derivative of this function. Specifically, it tells us to use implicit differentiation because we have two variables in this problem. We have an x and a y. And remember, when we're doing implicit differentiation, anytime we take the derivative of a y variable, we have to include dy dx. So to show that dy dx is that, we have to take the derivative. What's the derivative of x to the third? 3x squared. What's the derivative of y to the third? 3y to the what? Second power squared. Then we have to put a, because we took the derivative of a y. Then we set that equal, we have to do it to the other side as well, the entire equation. In order to do this for the 4xy, what rule are we gonna have to use? Product, okay? I'm gonna go just take out the 4, I'm not even gonna worry about the 4 right now. And I was gonna do product to the x and the y. So, excuse me, so remember, derivative, product rule, is the first times the derivative of the second, plus the second times the derivative of the first. So, the first is x, times the derivative of the second. What's the derivative of y? 1 dy dx, plus the second, which is y, times the derivative of the first, which is 1. So we have this. Now what we need to do from here is we need to basically get our dy dx's on one side, everything else on the other side, and then get it by itself. So okay.
Oh, yeah.
Okay. I'm going to subtract the 4x dy dx to the left and then subtract the 3x squared to the other side. So now that the dy dx's are on the same side, what can I do to the left? Because both dy dx is on the same side. Very similar to, remember when we were doing inverses and we had two y's? We had to get the y's on the same side, factor out a y. Same concept. This time it's just dy dx's. And then we divide both sides. So when we divide both sides, we'll get dy over dx is equal to 4y minus 3x squared all over 3y squared minus 4x. Y'all remember those three letters? Remember we used those back when we did proofs back in like the first unit last year? It's something that you can basically put to say that we have reached the final conclusion.
See, the whole time I completely forgot about the top thing, so I was looking for the derivative of that.
Jeez, yes. So you found the second derivative? Oh Lord, oh, I'll do that. So then it says, so everyone good? I know I scrolled up, everyone good? Then it says, we have to find the value of k. K was first told to us right here. It said that x equal to k, and it says the tangent to the curve is parallel to the x-axis at that point. What does tangent to the curve mean? When you see that together?
Oh, it's that means that the derivative equals that?
That means the derivative is parallel to the gradient, well, no, oh, sorry. Tangent to the curve means there's a line that's going to be parallel to the x-axis at a particular point on this curve at K. If a line is parallel to the x-axis, that means it has a slope of what? 0. So if it has a slope of 0 or a gradient of 0, then we could use the derivative, which we already know what it is. So we can do A, we can definitely do B. And we can set the derivative equal to 0 and solve. Now specifically, we're supposed to solve for K. K is equal to X. So we can plug in K for every X that we see. And when we do that, sorry, I kept that as X. Change it back to K. I need to do the same thing with Y. But what am I going to plug in for Y? How do I find Y? In general. Plug what?
Like 0 for X. No.
What was X equal to? What is X equal to? K. So plug K into the original equation and solve for Y. Okay? So when we do this, we are going to have to let's see, we're going to have to get our K's. Our Y's on one side. Let me see. What are we missing?
Onto the other side and
No. Hold on.
Is K on the left or right of that?
I see. My apologies. So what we can do, sorry, is back here, by setting the derivative equal to 0, we can actually here solve for Y here. And then we'll be able to use that to substitute back in to actually get our answer here. So anytime we set a rational expression equal to 0, we already know that it's just going to be the numerator equal to 0. So then if I solve for Y here, I'll add over my 3K squared, divide both sides. And now that I have my value for Y and I have my value for X, I can plug that back into the original equation. Okay? So I'm going to take my X, I'm going to take my Y, and then I'm going to plug that into my original. So that's going to be K to the third plus 4/3 K squared cubed 4 times K. So that becomes K to the third. What's 3 cubed?
27.
4 cubed.
64.
K to the what power?
6.
6, because remember, power to a power, you multiply. Then over here, 4 times 3/4 is just, and K times K squared is? Okay. And so, since we have a K to the third on the left, a K to the third on the right, this can become 27 over 4, 64, K to the 6 equals 2k to the third, because I just subtract over.
You subtract the k to the third over again? Or no, because you threw it over there again. You factor out k? No.
Don't factor out a k because they're on opposite sides.
Mm.
Trying to solve for k.
Ooh, you could divide.
Say again?
Can you divide by k?
Yeah. I mean, 1k or k to the third?
Oh, like k to the third. Yeah, on the other side.
When you divide with exponents, what do? So this becomes 27 over 64 k to the equals. So multiply by 64 over 27. And then is 128 a perfect cube? No? So then the 27 is, what is that? You can't simplify that though. Remember, cubes, you can pull out. So we know that this can be rewritten, I'll do it in a different color, as the cube root of 64 times the cube root of 2. The cube root of 64 is 4, cube root 2 over 3. I remember this was a paper 1 or paper 2, but if it was a paper 1, we would have been done back up there. Or paper 2, we would have been done back up there.
Wait, which one's the one that I calculated?
Paper 1.